What was the solution of our quadratic? The x-intercepts. We're looking at where did our graph hit the x-axis. Okay, we want to kind of figure out if there's other options for solving that. So we are going to look at it from the equations. Can I get the same thing without looking at, or without going through the whole graphing process? Now, the graph still certainly works. So you can graph it or use a graphing calculator and look for those x-intercepts. But we have other options. We have done factoring before, and that is the strategy we are going to use. When we factored before, we didn't have an equation, we just had an expression, so we're always going to set it equal to 0, factor, and then we'll get our solution from that. So if I gave you x squared plus 4x plus 3 equals 0. Remember when we factored this, we were looking for two numbers that multiplied to what? 3 and added to 4. What two numbers multiply to 3 and add to 4? Okay, 3 times 1 is 3, 3 plus 1 is 4. So x squared breaks into x. So this factored into x plus 3, x plus 1. And how could you check your answer with this factoring? You know, you could multiply it back out and see if it works. Now from here, the only way we get 0 in a multiplication problem is if one of these things is equal to 0. So what we're going to do is say, all right, now I'm just going to set both of those equal to 0. So I need to know, when does x plus 3 equal 0? And when does x plus 1 equal 0? So the first one, if you subtract your 3, we get x to be -3. This one, if we subtract our 1, x is -1. So our answer, the places where it would hit the x-axis, -3, -1. We're going to write it like we did yesterday as a solution set. Those are the x-intercepts. If you want to check it, you could graph it on your graphing calculator, and that should be the 2 points. I want you guys to take a look at number 3 and see if you can factor it for me. We need two numbers that multiply to a -2 and add to a +1. What are they? We'd have to do +2 and -1 since they add up to a positive. So now it's factored equal to 0. So we just set both of them to 0. What makes x plus 2 equal 0? If it's a -2. We set x minus 1 equal to 0. We have +1. So to write our answers, -2, +1. Do you guys remember doing this factoring before? So it's just like the factoring with an extra step of setting things equal to 0. Number 5. What would we do on that one? Multiply to a +21, add to a -10. So that's x minus 7 and x minus 3. Then set each of those to 0. So if we add the 7, we get +7. the 3, we get positive 3. I want to do number 5, and then I'm going to jump to the back side, and we're going to start jumping around just a little bit more. Sorry, not number 5, number 7. Because this one has a slight difference to it. When we factor this, what two numbers multiply to 25 and add to 10? Okay, everybody better stay with me here. What happens when you set those equal to 0? It's the same, right? We get -5 for this one and -5 for this one. Remember yesterday we talked about our graph? Sometimes it hits the x-axis twice, sometimes it only hit once, and sometimes it didn't hit at all, right? This is a case where it only hits once because we got the same answer twice. So when you write your answer, you only need to write it one time. You don't have to put it repeatedly. All right. I want to jump to problem number 9. And this one is a little bit different. Okay, so do I need to do the multiply to something and add to something on this one? How do I factor that? We take out an x, and that leaves me with x minus 8. So now if I set each of those equal to 0, the first one we just get x equals 0, the second one x minus 8 equals 0. Add our 8 and we get x equals 8. So we got two answers again, 0 and 8. Sometimes, if you only have two terms, you're just looking for greatest common factor on both. I want you to look at 15. All right, do we have enough terms to factor like different, or like the two parentheses that we were doing, multiply something and add to something? No. Do we have a greatest common factor? What did we do when we factored these? Yes, remember those are both perfect squares. It's a difference of squares. What is the square root of 4x squared? 2x. One gets a plus and one gets a minus. What is the square root of 81? Alright, so we're reviewing all of our factoring techniques right now. So then we set each of these equal to 0. So this one, if we subtract the 9, we get 2x equals negative 9. Divide by 2. So that gives me, I'm running out of space, negative 9 over 2. This one we add our 9. Divide by 2. And we get a positive 9 over 2. So for factoring, we need to check GCF. We need to check difference of squares if the GCF doesn't work. And if they don't work like that, then we're looking at the trinomials. All right, last ones. I just want to look at one at the bottom. Let's do number 21. This one's set up differently because it's not equal to 0. to start with. So first, we have to get everything on one side. And so if I subtract over my x squared, that gives me a 10x squared equals 8x. Okay, but it's still not equal to 0, so we need to subtract over that 8x as well. So it just becomes 10x squared minus 8x. And you could move it to the other side if you preferred. I just like to keep my squared term positive whenever I can. All right. When I'm looking at that, which strategy am I going to use here? We check, so we don't have enough terms for like the trinomial. So we check, it's either got a GCF or a difference of squares. So we have to see which one is the case here. Do 10x squared and 8x have anything we could take out? A 2x, so let's do that. So that leaves us with 5x minus 4. So now we set each of these equal to 0. 2x equals 0. Divide by 2 and x is just 0. 5x minus 4 equals 0. Add the 4. Divide by 5. And we get 4 for this. Alright, so it's really just going back to that factoring piece that we used to do and adding one more step to it where we set things equal to 0. Do you guys have questions for me? Okay. I want you all to practice.